Welcome to week 3. Over the past 2 weeks, you've learned PHP basics and string manipulation. You built an energy tracking receipt that processes raw sensor data into formatted output. But that script had a limitation. It followed a single linear path. It couldn't make decisions. It couldn't say, if the emission is above 1,000 tons, flag it as critical. And all that code was one long script, no reusability. Today we fix both problems. We'll learn conditionals, which let our code make intelligent decisions, and custom functions, which let us write logic once and reuse it everywhere. By the end of today, you'll have a complete emission calculation library, a set of reusable functions that any part of our Carbon Track platform can call. 3 hours, 2 major PHP concepts, 1 powerful result. Hour 1 teaches conditionals, the ability for code to make decisions based on data. We'll use this to automatically classify emission sources into scopes, determine severity levels, and handle different calculation methods. Hour 2 introduces custom functions wrapping reusable logic into named, callable blocks. We'll build functions for emission calculations, data validation, and report formatting. Hour 3 combines everything into a multi-file calculation library that becomes the foundation of our Carbon Track platform. Let me show you why today matters. Last week's homework had you processing 5 devices. Did you notice how much code you copied? The calculation logic was the same for each device. Multiply consumption by emission factor. The formatting was the same. The only things that changed were the input values. This is a code smell, duplicated logic that's fragile and hard to maintain. If the emission factor changes, you'd need to update it in 5 places. And our code couldn't make decisions. It couldn't automatically classify sources into scopes or flag high emitters. Today we fix all of this with 2 powerful tools, conditionals for decision-making and functions for reusability. Before we learn conditionals, let's understand what drives them. Boolean expressions. Every comparison produces a true or false result. Is CO2e greater than 200? True. Is the status verified? False. These yes-no questions are what conditionals evaluate. PHP has the standard comparison operators, greater than, less than, equal, not equal, and their inclusive variants. Remember from last week, always use strict comparison triple equal and triple not equal to avoid type juggling surprises. The spaceship operator is special. It returns -1, 0, or 1, depending on whether the left side is less than, equal to, or greater than the right. We'll use it for sorting later. The if statement is the most fundamental control structure. If the condition is true, the code block executes. If false, it's skipped. With else, you provide an alternative path. One of 2 blocks will always execute. With elseif, you chain multiple conditions, checked in order from top to bottom. The first true condition wins, and the rest are skipped. The emission severity classifier is a perfect example. We check from highest to lowest threshold. An 850-ton emitter hits the second condition and gets classified as high. The order matters. If we checked 100 first, everything above 100 would be classified as medium, and we'd never reach the higher thresholds. You can nest if statements inside each other for multi-level decision-making. Here we check 3 things. Is the entry verified? Is it a high emission? And does the user have permission to approve it? Each level narrows the context. However, deeply nested code, sometimes called arrow code, because the indentation looks like an arrow pointing right, is hard to read and maintain. As a rule of thumb, try to limit nesting to 2 to 3 levels. In hour 2, we'll learn the early return pattern with functions, which eliminates most nesting. For now, just be aware that while nesting works, it should be used sparingly. Logical operators combine multiple conditions. And, written as and, requires both sides to be true. Or, written as one, requires at least one side to be true. Not, written as fal, flips true to false and vice versa. These map directly to GHG reporting logic. Is this entry verified and above threshold? Is the user admin or manager? Is the device not active? Always use parentheses when combining operators to make your intent explicit. Without parentheses, operator precedence can produce unexpected results. And has higher precedence than or, so A or B and C means A or B and C, not A or B and C. When in doubt, add parentheses. Short circuit evaluation is a performance and safety feature. With AND, if the first condition is false, PHP knows the overall result must be false, so it doesn't evaluate the second condition. With OR, if the first is true, the overall result must be true, so the second is skipped. This is more than optimization, it's a safety mechanism. Look at the null check example. If $sensor reading is null, we don't want to compare null with a number. By putting the null check first with AND, PHP skips the comparison when the value is null. This pattern, check for null first, then check the value, is essential in our platform where data might be missing. When you're comparing one variable against many possible values, switch is cleaner than a chain of elseif statements. Each case tests for a specific value. If it matches, that block executes. The break statement is critical. Without it, PHP falls through to the next case. The default case handles any value that doesn't match, like our unknown fuel type. In our GHG platform, switch is perfect for emission factor lookup. Given a fuel type, return the right factor. However, modern PHP offers something even better, the match expression, which we'll see next. The most common switch bug is forgetting the break statement. Without it, PHP continues executing the next case, regardless of whether it matches. This is called fall through, and it's usually a bug, but sometimes it's intentional. Look at the second example. Multiple categories map to the same scope. By listing cases without break between them, they all execute the same code block. This is a clean way to group related values. The key rule: always include break at the end of every case, unless you're intentionally falling through. And if you are falling through intentionally, add a comment saying so. The match expression, introduced in PHP 8, is the modern replacement for switch in many cases. It has four major advantages. First, it returns a value you can assign the result directly to a variable. Second, it uses strict comparison by default, preventing type juggling bugs. Third, there's no fall through and no break needed. Each arm executes only its expression. Fourth, if no case matches and there's no default, PHP throws an unhandled match error, alerting you to missing cases. For our platform, match is perfect for scope classification, emission factor lookup, and status mapping. Notice how multiple values can share one arm using commas. This replaces switch fall through cleanly. Match true is a powerful pattern that evaluates Boolean expressions. Instead of matching a variable against values, it matches true against conditions. The first condition that evaluates to true wins. This is cleaner than a chain of if-else-if statements when you want to assign a value based on ranges or complex conditions. Look at the severity classifier. Same logic as our if-else-if chain from earlier, but much more compact, and it returns a value directly. The Scope 2 method selector shows priority-based matching. Prefer supplier-specific factors, then recs, then grid average. We'll use match true extensively in our platform for emission calculations, status display, and permission checks. The ternary operator is a compact way to choose between two values based on a condition. It's an expression, meaning it returns a value you can assign to a variable, pass to a function, or embed in a string. In our platform, we'll use ternaries for display formatting, choosing tons versus kilogram based on magnitude, showing no notes when notes are null, displaying trend arrows based on emission changes. However, there's a strong rule: never nest ternary operators. $A equals $X question mark, $Y question mark, A, colon, B, question mark, C is nearly impossible to read. If you need nested conditions, use match/true or if/else. The ternary is for simple binary choices only. The null-coalescing operator affirmation is one of PHP's most useful features for our platform. It returns the left side if it's not null, otherwise the right side, the default. This replaces verbose isSet checks with clean, readable code. We'll use it everywhere, defaulting URL parameters, providing fallback values for configuration, looking up emission factors with a default of 0. You can even chain it. Try a custom value, then a default value, then a hard-coded fallback. The assignment variant, affirmand, sets a value only if it's currently null, perfect for initializing configuration. This operator eliminates a huge amount of boilerplate null checking code. When PHP is mixed with HTML, as in templates, the curly brace syntax becomes messy. PHP offers an alternative syntax, if with end if, for each with end if. This reads much better in HTML context, because you can clearly see where each block begins and ends. The is a short echo tag, it outputs the expression directly. We'll use this alternative syntax in our early templates before switching to Twig in week 10. Notice the ternary inside the class attribute, conditionally applying a CSS class based on entry status. This is a common pattern for visual differentiation in tables and lists. Here's our first real platform function scope classification. Given an emission category, it returns the correct GHG protocol scope. Match is perfect for this because each category maps to exactly one scope. The function throws an exception for unknown categories rather than silently returning a wrong value. This is fail-fast design. In a real platform, bad data should cause an error, not a wrong calculation. We list all 15 Scope 3 categories from the GHG protocol. This function will be called every time a new emission source is created. The user selects a category, and the system automatically determines the scope. This alert system combines everything we've learned. The match expression returns an array with severity level, icon, and color, giving us structured data for display. The trend analysis uses comparison operators to determine direction and magnitude. The target check compares against a science-based target-aligned reduction pathway. Notice how each conditional serves a specific purpose. Match classifies severity, comparisons determine trend direction, and the ternary formats the output. In our web application, the severity level will determine CSS styling, the trend will show as chart arrows, and the on-track status will drive dashboard alerts. This example shows how conditionals work together in a real scenario. The factor lookup has 3 tiers. Check combustion fuels first, then electricity by region, then travel modes. If nothing matches, it warns and defaults to 0. Then a year adjustment is applied. Older emission factors are slightly higher because they're less accurate. This multi-level decision tree is exactly what our emission factor service will implement. The logic flows from most specific to most general, with clear error handling at each level. In our platform, this logic will eventually read from a database instead of hard-coded values, but the conditional structure remains the same. Take 10 minutes for this exercise. This is a real business rule from our platform, the entry lifecycle. Think about how to structure your conditionals. You might use nested if statements, or you might use match for the status transitions, and separate if checks for role and ownership. The key insight is that there are 2 types of rules: which transitions are valid, based on status, and who can perform them, based on role and ownership. Try to keep your code clean and readable. When you're done, test all 5 test cases. You've now mastered decision-making in PHP. Your code can classify emission sources into scopes, determine severity levels, look up emission factors intelligently, and enforce workflow rules. The most important takeaways: use match for mapping values to results. Use match true for range-based classification. Use question for default values, and always use strict comparison. These tools transform our platform from a simple calculator into an intelligent system that makes decisions based on data. Now let's learn functions, the tool that makes all this logic reusable. Look at the difference. Without functions, you repeat the same calculation for every device. If you need to change the formula, say you add a new greenhouse gas adjustment, you change it in 100 places. Miss one? Bug. With functions, you write the logic once and call it with different inputs. Change the formula in the function, and every caller gets the update automatically. Functions also give meaningful names to operations. Calculate emission tells you what's happening, while KWHH times 0.47 requires you to figure out the intent. This is the most important concept in programming abstraction through reusable code. A function is declared with the function keyword, a name, parameters in parentheses, and a body in curly braces. The return statement sends a value back to the caller. You call a function by its name, followed by arguments in parentheses. Parameters are the variables in the function declaration. They're like slots waiting to be filled. Arguments are the actual values you pass when calling. The return type after the colon tells PHP what type the function will return. For calculate emission, we accept 2 floats and return a float. This function encapsulates the core GHG formula, activity data times emission factor. Simple, but used thousands of times in our platform. Type declarations are your safety net. When you declare float $activity data, PHP will throw a type error if someone passes a string that can't be converted to a float. This catches bugs at the function call, not deep inside a calculation where they're harder to trace. For our GHG platform, type safety is critical. A wrong type could lead to a wrong emission calculation, which could mean regulatory noncompliance. The void return type declares that a function doesn't return anything. It just performs a side effect like logging. Always declare types on your functions. It's a small effort that prevents large bugs. Functions can return any type. The GWP calculator returns a float. The severity classifier returns a string. The scope totals function returns an array with multiple computed values. Returning an array is a powerful pattern. It lets a single function compute and return multiple related values. Our calculate scope totals function returns not just the totals, but also the percentages, saving the caller from doing that math separately. Notice the division by zero check. If total is 0, percentages default to 0. This defensive programming prevents crashes when there's no emission data. Nuevo types solve a common problem. What if the data doesn't exist? Float means the function returns either a float or null. This is perfect for lookups where the key might not exist, like searching for an emission factor for a fuel type not in our database. The caller is then responsible for handling null. Union types, introduced in PHP 8, allow multiple types. Int float accepts either integers or floats. This is useful for our unit converter where input might be a whole number or decimal. Notice the creative use of match with string concatenation for the conversion direction. Kilogram to tons is expressive and easy to extend. Optional parameters have default values if the caller doesn't provide them. The defaults are used. This makes functions flexible without making every call verbose. Our calculate emission function can be called with just the activity data and factor for a quick kg result, or with additional parameters for different units and precision. The rule is simple. Required parameters come first, optional parameters come last. You can't put an optional parameter before a required one. This design pattern is everywhere in PHP's built-in functions. Number format, n, decimals, has the same structure. Named arguments, introduced in PHP 8, are a game changer for readability. Instead of passing values by position, where you have to count which parameter is which, you specify the parameter name. Source ID 1 is much clearer than just 1. Named arguments have two additional benefits. You can skip optional parameters in the middle. We skip notes but specified status. And you can pass arguments in any order. For functions with many parameters, like creating an emission entry, named arguments make the code self-documenting. Anyone reading the call immediately understands what each value represents. We'll use named arguments extensively in our platform. Not every function needs to return a value. Void functions perform actions. They display output, write to files, send notifications, or log events. The void return type documents this intent. The return statement in void functions exits the function early without a value. This is the early return pattern I mentioned earlier. Instead of nesting conditions deeply, check for special cases at the top and return early. In log audit entry, we check if user ID is null first, handle that case, and return. The normal case follows without nesting. This pattern keeps code flat and readable. We'll use it extensively in our controllers. This is where functions become truly powerful composition. Each function does one thing well. Get emission factor looks up a factor. Calculate emission does the math. Format CO2e formats the output. Classify severity determines the alert level. Then process emission source composes all four into a complete workflow. If the emission factor lookup fails, it returns early. Otherwise, it calculates, formats, classifies, and displays. Each function can be tested independently, reused in different contexts, and modified without affecting the others. This is the single responsibility principle. Each function has one job, one reason to change. By default, PHP passes arguments by value. The function gets a copy. Changing the copy doesn't affect the original. This is safe, but means the function can only communicate back through its return value. Pass by reference, marked with _ before the parameter, gives the function access to the original variable. Changes inside the function affect the caller's variable directly. The running total example shows this. Each call to add emission to total accumulates into the same variable. The validation example is even more practical. Each validate field call can add errors to a shared array. We'll use this pattern in our form validation, where multiple fields are checked and errors are collected into one array. As your project grows, you shouldn't have everything in one file. PHP's require once includes another file exactly once. If it's already been loaded, it's skipped. The dir magic constant gives the directory of the current file, making paths reliable regardless of where the script is run from. We organize functions by concern: calculations in one file, validation in another, formatting in a third. This is the beginning of modular architecture. Each file is like a mini library that can be included wherever needed. Always use require once for function files require loads every time, which could cause function already declared errors, and include only gives a warning if the file is missing, which could let your script continue with undefined functions. This is our first real library file. 5 functions, each doing one thing: calculate emissions, calculate GWP, compute year-over-year change, calculate a reduction target, and check if current emissions are on track. Notice calculate GWP uses named parameters. With defaults, you can call it with just CO2 or any combination of gases. Calculate year-over-y change returns null if the previous value is 0 to avoid division by 0. Calculate reduction target uses POW for compound reduction. A 4.2% annual reduction compounded over 5 years gives a different target than a simple 21% reduction. This library becomes the mathematical core of our platform. The classification library contains functions for categorizing and labeling data. Classify scope maps categories to GHG protocol scopes. Get emission factor handles both fuel-based and region-based lookups. With a single function, if a region is provided, it returns the grid factor. Otherwise, it returns the combustion factor. Classify severity returns severity labels. Get scope label converts scope codes to human-readable labels. And determine reporting period parses a date into our 2025 Q1 format. Each function is small, focused, and testable. Together, they provide the intelligence layer of our platform. The validation library follows a consistent pattern. Each validation function returns null if valid, or an error message string if invalid. This convention makes composition easy. Validate emission entry calls multiple validators, collects all non-null results, and returns an array of error messages. An empty array means all validations passed. Each validator is small and reusable. Validate required works for any field. Validate numeric for any numeric input. Validate emission entry orchestrates them all for a specific form. The array filter at the end removes null entries. The null returning convention makes this clean. In our web application, the controller will call validate emission entry, check if errors is empty, and either proceed or display the errors. The formatting library handles all display concerns. Format CO2e produces consistent emission value strings. Format trend calculates and formats year-over-year changes with direction arrows. Format severity badge pairs severity levels with icons. Format report header creates the report title block using Heradoc. Format tuffers for aligned columns. By centralizing formatting, we ensure consistency across the entire platform. Whether an emission value appears on the dashboard, in a report, or in a log file, it's formatted the same way. Change the formatting in one place and it updates everywhere. This is the dry principle. Don't repeat yourself. Variable scope is a critical concept. Variables created inside a function exist only inside that function. They're local. Variables created outside a function are invisible inside. PHP functions don't automatically see outer variables. This is actually a good thing. It prevents functions from accidentally modifying external data. If a function needs external data, pass it as a parameter. This makes the dependency explicit. Constants defined with const or define are the exception. They're accessible everywhere. For truly fixed values like GWP factors or grid emission factors that never change during execution, constants are appropriate. The global keyword exists but should be avoided. It creates hidden dependencies that make code hard to understand and test. This is the complete pipeline using all 4 libraries. Data comes in from a simulated form. Step 1. The system automatically classifies the scope based on the category the user doesn't need to know which scope a boiler belongs to. Step 2. Validate all fields. Step 3. Look up the emission factor, calculate CO2e, determine the reporting period, and classify severity. Step 4. Format and display. Each step calls functions from our libraries. The main script is just orchestration connecting the steps. The actual logic lives in well-tested, reusable functions. This is exactly how our web controllers will work. Receive input, classify, validate, calculate, format, respond. Testing is how you verify your functions work correctly. The pattern is simple. Call the function with known inputs, compare the result against the expected output. If they match, it passes. If not, it fails. Test normal cases, does the basic calculation work? Test edge cases, what happens with zero input, null values, unknown fuel types. Test boundary conditions, what's the severity at exactly 1,000 tons? This manual testing approach works for now. In professional PHP, you'd use PHP unit for automated testing. But the principle is the same. Define inputs, define expected outputs, compare. Always test your functions before using them in the main application. Take 10 minutes to build this validation function. Use the individual validators from our validation library as inspiration, but build a device-specific function. Each check should add an error message to the array if it fails. Remember, return the array of errors. Empty means valid. Test with both the valid and invalid cases to make sure all your checks work. Think about the order of checks. Should you check required before checking positive? Yes. If the value is empty, checking if it's positive is meaningless. You've now learned to write reusable, typed, testable functions. You can declare functions with parameter types and return types, use optional parameters and named arguments, organize functions across files, and compose small functions into complex pipelines. Most importantly, you've built 4 library files that form the core of our Carbon Track platform. These functions will be used every week from now on. In week 9, they'll become methods on classes. In week 12, they'll become part of interface-based services. But the logic inside them stays the same. Functions are the building blocks of everything. Welcome to the lab. For the next hour, you'll build and integrate a complete function library. You already have most of the code from the lecture. Now you'll organize it properly, add a few more functions, write tests, and create a report generator that processes multiple emission sources. This is hands-on coding time. Create the folder structure first, then build each library file, test it, and finally create the report generator. I'll walk you through each step, but code along rather than just copying. Let's start. Create the functions folder and this file first. Type each function carefully, paying attention to the type declarations and return types. The convert unit function is new. It handles common unit conversions we'll need. Test each function mentally as you write it. Does calculate emission for 1002 return 2000? Yes. Does convert unit 1000 kilogram tons return 1? Yes. Does calculate yo-yo y change 90, 100 return minus 10? Yes, because 90 minus 100 divided by 100 equals minus 0.1 equals minus 10%. Get these right because the rest of the pipeline depends on them. The classification library is mostly match expressions, clean, readable mappings. I've added icon for status display. Each function is small, most are 5 to 15 lines. That's intentional. Small functions are easy to understand, easy to test, and easy to modify. When the EU updates emission factors next year, you change one function. When a new Scope 3 category is added, you add one line. This maintainability is why we separate concerns into focused functions. Notice the validation pattern. Each validator returns null for valid data or an error message string. The composite function validate emission entry calls multiple validators, collects the results, filters out nulls, and returns only the error messages. Each individual validator handles edge cases. Validate numeric skips null and empty values because validate required handles those. Validate date checks both format validity and future dates. This layered approach means you can compose validators in different combinations For different forms, the same validate required and validate numeric work for any input, not just emission entries. The formatting library provides consistent output functions for our entire platform. Format percentage includes a plus sign for positive values, plus 12.4%, is more informative than just 12.4%. Format trend combines the change calculation with the arrow display. The report functions header, footer, table row, scope summary use sprintf for precise alignment and box drawing characters for visual structure. Every display function is here, centralized. When we move to web output in later weeks, these functions will generate HTML instead of text, but the interface remains the same. Run this test script to verify all your functions work. The assert helper function compares actual versus expected and reports pass or fail. We test normal cases, edge cases, and boundary conditions. If all tests pass, you can be confident your library is correct. If any fail, fix the function before continuing. Notice we test both positive and negative scenarios. Valid data should pass, invalid data should return appropriate errors. Testing isn't just about proving things work, it's about proving they fail correctly too. Run this with php tests/testall.php and fix any failures. The report generator starts with company data and an array of emission sources. Each source has a name, GHG protocol category, fuel type, activity data, and unit. Some sources have custom emission factors. Refrigerant leaks use the GWP of the specific refrigerant, not a standard combustion factor. The employee commuting calculation uses the multiplication right in the data definition, 200 employees times 25 kilometers per day times 220 working days. This data structure will eventually come from a database, but for now we hard-code it for the demo. The processing loop iterates through each source, classifies its scope, looks up the emission factor, checking for custom factors first, calculates CO2e, and accumulates scope totals. The continue statement skips sources with missing emission factors rather than crashing. We log a warning and move on. The $process sources array stores all the calculated data for later display. This pattern iterate, classify, calculate, accumulate is the core processing loop of any GHG inventory system. Every entry gets the same treatment: scope classification, factor lookup, calculation. The functions handle all the complexity. The report output uses all our formatting functions. Sources are grouped by scope with section headers. Each source shows its emission value and severity badge. The scope totals section shows both absolute values and percentages. The trend analysis compares against the baseline, calculates the SBTI-aligned reduction target, and checks whether the company is on track. Every number is formatted consistently with number format. Every label comes from a function. If you want to change how severity badges look, you change one function. If you want to change the number format, you change one function. This is the power of a well-structured function library. Your numbers might differ slightly based on the exact emission factors and rounding, but the structure should match this. Check every section: scope headers, individual sources with severity badges, scope totals with percentages, grand total, trend analysis, and on-track status. This is a professional quality GHG inventory report produced entirely by your PHP function library. Every piece of it, from the scope classification to the severity badges to the reduction target, comes from a function you wrote today. This is what our Carbon Track platform will generate, eventually from a web interface pulling data from a database.